Hello, and today I'm going to be talking to you about dark matter. Dark matter makes up 96% of the entire matter which is in our universe. But what we see and experience around us is only a very tiny percent of the amount of matter that actually exists. A Swedish physicist in the 1900s decided to experiment on the amount of matter, and he decided to measure the amount of matter in a certain galaxy. He done this by using the amount of the velocity at which the galaxy was moving, but he found out, according to his calculations, that the weight of the galaxy needed to be 160 times greater for it to be traveling at the velocity that it was. And he concluded that there was missing matter, or dark matter as we now call it, which has a property of gravitational pull, of heavy gravitational pull, because it is a heavy particle. But only a small percent of it is actually heavy. There are two types of dark matter, which is baryonic dark matter and non-baryonic dark matter. This baryonic dark matter can only form into atoms and have the can only have mass, and so have the gravitational pull required to hold the galaxies together and accelerate them at the speed at which they were traveling. This non-baryonic dark matter, although still has the gravitational pull, it cannot form into atoms, hence it's non-baryonic, because baryonic is a type of classification of atom, which means that it cannot obviously form atoms. We know that dark matter exists because of an effect called gravitational um, gravitational lensing, which is when, if you have an observer, say we were looking at a certain galaxy through a telescope, and the telescope was the observer, the rays of light which are passing from the galaxy to the telescope, if they were passing through a cloud of dark matter, what would happen is that according to special relativity, the light would be bent by dark matter due to its gravitational properties, meaning that a light cone, would be formed from the galaxy to the hemisphere, to both of the hemispheres of the cloud of dark matter, which would mean that the light would be distorted and skewed to one side, depending on the angle at which we were seeing the galaxy at. And because of this, we know that there is a certain matter with heavy gravitational pull, which we decided to call dark matter. It was actually named by William Harvey, the term dark matter. What effects will this have? Well, we know that it will have a dire effect on the outcome of our universe, because right now, what we predict will happen in the future is that due to high entropy levels, the disability of a system, and so the disability of a system to work, will mean that our universe will eventually grow so big that the heat escaping will be far greater than the heat able to be conserved, and so there'll be more heat. There'll be heat, the same amount of heat, spread out over a greater amount of area, meaning that less heat will be able. The less heat will be usable by us, and so our universe will turn into a ice. It will just turn into ice. But if with the added effects of dark matter, it will mean that the universe will actually stay roughly around the same area as it is now, because of the anti gravitational effects, which will be pulling away, which will be pulling inwards rather than pulling away, due to the effects of the Big Bang. So the effects of the Big Bang will be pushing the universe away, while the effects of the dark matter will be keeping the universe in, holding the galaxies together, And so this is an effect which we will have by finding out more information about dark matter. And yeah, that's it.